what we've got here is a Casio HL-802, which I bought as a faulty calculator, and turning it on you can see it's come up with a C there, which isn't right, and if you fill it with 8s it's just junk. So there's something obviously wrong with the display part of this. So I'm going to take this apart. I'm not going to try and repair it, I don't think, unless it's an obvious fault, and then I'm going to have a go at decapping the ICs on this calculator. It's one that I hadn't really heard of before, but it's not a programmable, it's a very simple calculator, basically 4 functions and a few extra percent and square root. Right, batteries out. Older calculators are much nicer to take apart because they're usually just screwed together. The newer ones can have all sorts of glue and clips and such like. Let's see if we can get this open. I think this might be clipped together. No, it's only sort of clipped together. Let's see what we got. So there we go, circuit board. Let's take that out. Got some wires for the battery there. Let's just take those off. So desolder that, or maybe I'll desolder it from the board later on. There we go. What have we got? PCB, insulating plastic, the normal membrane keys, quite dusty, and some keys which are going to go all over the place, as they always do. There we go. Let's desolder the supply. We've got plus and minus on there, so we can always put it back if we want to. There we go. 1, 2. Oh yes, nice smell of old flux there. It's the smell of the 70s. Right, so come out. Where's that going on? I don't really want to destroy it if I don't have to. Oh, there we go. So that's a standard Casio power switch. I've seen that one a few times before. Or a similar design. Move that out of the way. What have we got here? So the display, that's interesting. It's an LCD display which is attached to the PCB with these horrible carbon connections. They're not easily repairable. So the display actually lives that way round, so the writing's that way. Can't really see anything obviously wrong. It might be that the chip is broken. So what have we got here? A Toshiba T3708S. I think we'll remove that. Let's put that in a vise. It'll make it a lot easier to actually hold everything. Otherwise I need 3 hands. Alright, let's not put it that way. Let's try putting it the other way. Let's try it like this, shall we? A bit of flex there. Let's try and get it out. Heat into that. Yeah, we've got melting of solder. And we've also got some crinkling of plastic LCD connector. Oh well. There we go. Chip out. Let's not break the circuit board. Right. One IC. Very few other components. Capacitor, what looks like probably a capacitor and a couple of resistors. And a dodgy LCD. Which is even dodgier now. It's a bit of a shame, but I don't think that's a problem. Let's take that off and see if there's any. Let's see if there's any indication of what the problem was. Can we peel that off? Yes. No, can't see. There's gold contacts there. Looks fine, really. Oh well. It's the end of that calculator. This is the Casio HL-802 calculator chip, which I've decapped, and I'm going to have a quick look around the chip. It's quite interesting. Over here we've actually got a part number, a designation for it, a C708. Now I've had a look for this and I can't find a lot of information about it. I suspect it's some sort of microcontroller. If we go back up here and just along the edge of the chip, there's a lot of drivers. I think they're resistors, and then we've got a G there. I think that's ground, so they've helpfully labelled that for me. I think that must be the ground of the chip. Well, maybe. That's if that's a G. Further along there's various components, and over here we've got the manufacturer, so it's Toshiba. Now that was on the chip, so that's not a surprise, but the C708 is a bit of a surprise. That wasn't the number that was on the chip. There's a few test patterns there showing the layers. There's not too many layers on this die, so that'll make it easier to do any reverse engineering. More pins, so there's LCD drivers on this chip, and there must be a keyboard scanner. I think that's probably it. Power will be the other connections. That's interesting. What we've got there. I'm going to capture a load of photos and then stitch them together and get a die shot of this chip. That's an interesting area there. That looks disconnected from anything else. That's quite strange. Maybe that's another test pattern. And further down here, and that's interesting, we've got an N and a P. So looking at that, that looks like that might be an NPN transistor and a PNP transistor maybe. Although actually looking at the areas there, they look exactly the same, so maybe not. I'm not sure what that is. So that's the outside of the chip. All the pads for the bond wires, and another test pattern in the corner there. Over here, let's have a look up here. So various circuitry, various logic, and back down again. So here, this is interesting. So I think this is a set of memory registers, bits. So I think this is RAM for some purpose. It might be something to do with the LCD display that requires some memory to store the segment information. But that's what that looks like. There's another bank of it there, quite a lot of it, and another bank there. Now this looks like a ROM, so I think this stands a good chance of being the code for this microcontroller. And looking at it, that's going to be pretty easy to decode and actually get ones and noughts from that. Then of course we've got to get it into the correct pattern of bytes or whatever word size this microcontroller is. I did have a little look on the internet, and Toshiba do a 4-bit microcontroller. So this could be a 4-bit microcontroller, in which case we should see a very small data bus. So running down here, we do have, on the left hand side there, we do have 4 lines running down. So maybe this is a 4-bit microcontroller, and this is the instructions. So there's a bit of what looks like address decoders there. I think they're counting in maybe binary, some other sequence. It's very difficult to look at this on the microscope. I really need a die shot, so I'm definitely going to stitch some photos together. There doesn't seem to be necessarily enough logic for a microcontroller, so if there is one, it's going to be a very simple one. And some interesting decode there. That could be an instruction decode, perhaps. That looks a little bit like some sort of data stored in a matrix. There's a few little areas like that. So I think maybe this is a microcontroller, and that's interesting as well. That's very interesting there. Some sort of matrix of connections. That does look... yeah, maybe there is enough logic here for a microcontroller. I'll have to see if I can find a similar die shot. Maybe someone's done a 4-bit microcontroller from Toshiba. No, that's interesting as well. Another matrix of data. So these could be... maybe they're character generators, or maybe they're instruction set codings. Not sure. But anyway, this is the decap chip from the HL-802.